So hello one and all. What we're going to do today is go over static timing of 16 valve engine. Now there's a couple of things what can go wrong. As we know from the auxiliary shaft, if you do that too tight, the tension on it, you can have detrimental effects on the bearings. So what we're going to do is go over a slow time, how to set up timing on the 16 valve engines. So here we have the engine. Now there's nothing on this, and I'm just going to go over using the used parts that came off it just for principle. So imagine we're at this situation, you got your time bit off, you want to start again. First things, get the cams timed up. Now from the previous video we know about the cam timing chain, so bearing in mind if that's been done, cool. Now we need the top of this timed up. Now there's a marker on the cam pulley which should align with the V in top. As you can see, that is the marker on the cam pulley aligning with the marker on the rocker cover. So now we know the cams are lined up, that's one bit. Now you come to this shaft. On an 8 valve engine, this is important to time this up. There is a little indent here which should line up with the plastic housing. On an 8 valve, this auxiliary shaft drives the oil pump and also drives the distributor. This is a 16 valve. All this shaft does is drive an oil pump, so it does not need to be timed up anywhere. So wherever it sits, wherever it lands, that's fine, not make any difference. So that's timed up, ignore that. Now we need to get on the crank. Now these are known for having not the best fitting plastic pulleys, plastic covering, so they should sit on there and you have an indication mark on here. But what you need to know is whether the piston is actually lying with where it should be, because you've got a bit of play in this, where if it couldn't be screwed on right, when the actual pulley's on, you've got a bit of play in there as well. So what we want to do first, the engine is at TDC, so what I'm going to do is just put the pulley on here loosely, just so we can see where it's at. And on the back of the pulley, you have one of the recessed holes, has a little sort of shoulder in it. That is the hole that lines up with the little nipple that's on this. So we need to put that on there. And as you can see, with no bolts in it, you've got a fair bit of play in it. This only lines up one way with the nut holes that go into it. So what we need then is the bolt, which is down here. So just put one of these in quick. These aren't the right bolts, they were just whatever ones were in it. So that's on there. So as the spark plugs are out, I've just got a metal tube in there which goes through the head, through the spark plug hole, and just rests on top of the piston. So as we turn the crank, that pole is going to move up and down, so we know the piston is actually at TDC. So to check the piston's at TDC, which is top dead centre, I'll put a little line on that rod there. Now all I'm going to do is move the pulley down. And as you can see, that's disappeared. Now as you come back up, that line should then reappear. And you notice the line has stopped, and now it's starting to go back down because the piston's going back down. So you bring that back round clockwise, it's coming back up, and then it pauses for a second. It starts to go back down. So what you want to do is get it to the point, see I'm going up and down there, get to the point it stops still and doesn't move, and then hold that there. What we're going to do now is get the plastic cover on. This needs to be, when you put it on, it needs to be tight. So you can use the alignment marks to get things right. So that's on there nice and tight, and it's not moving anti-clockwise or clockwise. So that's good, how we want that. And then again, getting your right pulley marking on the back of there, line it up with the nipple on the crank pulley. Like so. What you bolt in. Should have got a shorter bolt. And we can see from the marker that it's not in line, so I'm just going to rotate it back out of the way. So this is the marker we're looking for, that arrow there lines up with a line on that crank pulley. So all we're going to do is gently move it around until it's as close as you can get to the centre of that arrow, which is there. As you can see, it's pretty much bang on. Right, so now we've got that aligned with the timer marks, that's aligned. Now we want to take these back off and then start getting the belt on. So what we want to do, remove these gently without trying not to turn anything. What we're going to do once this is off, we then want to put a little, use a permanent marker, just put a little mark where this pulley is versus the housing, just so we know if we have moved it, it's easier to see. Because if we move the top, we can see because the alignment mark's there, but if you move the bottom, you can't see too clearly. So what you want to do is get your pen, pick a point, any point really. I'll go, well actually you can see this top bolt hole is in line with the top of that one. So I'm just going to colour the top of that tooth in, up there to the top of that. So with the engine, well the crank at TDC, the time marks lined up, we've taken it off and then we've marked the pulley. So those two bolt thread holes are bang in line. So what we've done is just put a permanent marker line across there. So now when we start getting the belt on, if we move this for any reason, you know where the mark is, so we shouldn't have an issue when you get back together. So now let's get the belt on. Right, so I'm going to put the belt on. So what we want is slack on this side of the belt, because that's where the tensioner is. If you've got slack this side, you've got the tensioner's not going to do anything to take the slack out. So ideally, there's many different ways you can do it. Start on that. See, there, you've got a nice bit of slack, tautness there. This comes round, bottom pulley, and hold top and bottom like so, and then just swing this up and under. Become a bit fiddly. You shouldn't have to, when you're putting time belts on, you shouldn't have to force anything. You should just nicely slide over. Just need this top cam to line up, which should give us the play with the gap we need. There we go. Right, so it's just sat on there now, so all we need to do, plop that on there. Then, as you can see there, the top pulley hasn't moved, the bottom hasn't moved, doesn't matter about that. Got a nice bit of tension there, this nice bit of tension up there, and then we've got slack this side, which is fine, because that's what the tension is for. So all this does is get moved around, so we've got tension. So what I'll do is tension that next. So now we're going to tension it. Now the tensioner has two little holes in there. You can get special tools for these, or just get a pair of circlip pliers. They're plenty good enough to do the job. They're nice and tapered and strong, so you can get a fair bit of the edge inside. So what you want to do, again on these belts, this belt, once this is tight, you shouldn't be able to turn this belt more than 45 degrees without a decent amount of force, which to different people can mean different things. But so you've got those in there. All you want to do, turn the tensioner anti-clockwise, and you can see taking the slack up in the belt. So what you want to do is turn it just so it takes the slack up until there's resistance, and then see that I can turn that easily nearly to 90 degrees before I can feel resistance back through this. So what you want to do, once you've got slack up there, turn it a touch more, and what you want to be able to do is hold this belt, twist it, and when it gets to approximately 45 degrees from its straight, you should be able to feel it pull back on this, as in all the tension touching back on this. So you hold it tight. I've just got that to 45, and I can feel it pulling this pliers back. So that's where you want it. And then from there, should have got a spanner out in the first place. So again, on there. Yep, up there. So just give that a nip up, take those out, and we've got a nice bit of tension there. So I can turn that. I mean, yes, you can grab the belt, you can turn it to 90 degrees, but that's putting a hell of a lot of force on the belt. Remember, all the belt is doing is staying in there and just pulling around in a circle. This tension's got shoulders on it, so it keeps it in a straight line. So what you want to do is have that to the point you can get that to about 45 degrees before you get an excessive amount of resistance. Right, so just to see it from a better angle, got the belt here, it's all tight, lines up, lines up. So there, you've got the belt straight. So 45, about there, just to that point, you can feel a nice bit of resistance. To push it any further past, you're really putting some strain on there. So that is what you want, 45 degrees. On the 8 valve, it's 60 degrees roughly, just because of the position of the cam is slightly different and a bit higher, so you've got a longer section. Again, this is the main problem with doing this too tight. This is too tight. Again, all this is being pulled in. That won't move, and that won't move. But what happens is you've got so much tension on this belt, it forces this pulley this way. And again, like one of the other videos I showed you, if you go back and have a look, that's what destroys these bearings. It puts so much force on the bearing shell on the inside of here, having the cam belt too tight, that it causes it to just fall apart. And then with the leverage effect, again on the shaft, moves with the shafts there, pulling this side, it pushes that side out, which then wears out the rear bearing to the point it's that thin it just spins itself around like it has in this one. So that's the cam belt, all in all. Very simple. Again, the marks haven't moved on there, the marks haven't moved on there. We don't worry about that on the 16 valve. It's all timed up, that's tensioned up. So all you can do, leave that nipped up, and what we can do is rotate the engine around a whole 360 degrees till the time marks line up again, and then check the tension again. So we'll do that next. Now, the reason you want to turn this around 360 degrees is to make sure, again, the timing marks line up, and to make sure if you've got it wrong, you'll have no interference in the engine. Because if you do it like this, get it back, start the engine back up, and something goes wrong because you haven't done something right, that's where things can go wrong. If you turn the engine around by hand and something locks up, it's better to do that than have a starter motor trying to force it around. So again, we're just going to turn the engine around clockwise, nice and steady. This is also easier to do if you're doing a time belt, is take your spark plugs out. Ideally, if you're doing a time belt, you change the plugs at the same time, because if you've got spark plugs in, when the piston comes up and builds compression, it's got a bit of a jump to go over it. So the spark plugs out, you've got a nice easy movement to turn the engine around. As you can see, the pole at the top's coming up and down with the piston. We are now back on this timing mark there. So that's on there. This one isn't timed up because we haven't done a full rotation yet. So turn this around again. As you can see, this marker here starting to come back around to the top. I'll just take that out of the way. Don't need it anymore. So we're coming back round, slow yourself down, looking at the top one first, get that to the point, that's bang on in the top bottom of there. Yep, so that's bang on there, and the bottom is bang on. So we know then that our time marks have worked, that's lined up where we've marked it. So once we're all happy with that, we've turned it all around, 360 degrees, time marks lined up, so we know the engine's timed. Again, we don't worry about that. Tension is still there. You can turn this belt. It is an old belt, don't worry about that. So again, just to the point you're hitting sort of 45 degrees is where you're building up a bit of resistance, so that's perfect. Okay, any tighter than that, again, you're going to run into problems with it. So once you're happy with that, that nut just needs to be torqued up to 45 Newton meters. And when you're putting these on as well, they're quite self-explanatory. It can only fit on one way. Well, it can fit on two ways. You put it on one way, it won't work. This centre housing, the shaft the bearing sits on, is more proud on the other side of it. So this touches the engine, and then when you tighten up, that is against the engine and not moving. It's just the outside that moves. You put it the other way around and tighten it up, the whole lot is locked up. So that is the timing belt, or cam belt, however you want to say it, on the 16v engines. This is the same on all VW 16v engines, really. Yeah, so it's pretty self-explanatory, pretty simple. The time marks, again, from the previous video, check your measurements, get that timing chain changed, align the cams up first, nice line up there, align the crank up with the cover on and the pulley. Happy with that, take it off, mark the pulley, and then all we do now, once we've got that, we'll put the plastic cover back on, which should fit nicely round about. And this is just a confirmation of everything's lined up where it should be. So that's in there. Line these bolts up. So that's on there. And again, the pulley, the correct recess hole on the nipple, down there. And that lined up right. And there you go, and that lines up perfectly with the indent on there. So we've done everything by the book on the timing marks. You've got the tension right, nothing too much than 45 degrees. We know the piston was at TDC with the bar in there, so everything's lined up. So once you're happy with that point and everything's torqued up, you can put it all back together, plug everything back in and start it up. So hope that was helpful to someone. Again, important bit, tension on there, otherwise these bearings, shafts and the auxiliary shaft, you can't change them with the engine in the car. It's a complete strip down to get those done, and they are not expensive, but they're just very hard to get done. So yeah, if you're worried, I suppose, if you've had your engine, you're worried it's been over tensioned, you can see if there's any free play with the cam butt off, see if there's any movement in the pulley. Actually, I'll do that next, and then you'll see. So, with everything off, you want to ascertain whether your bearings are shot or not. Easiest thing to do is to literally pop the end of the shaft out if you can. So what you want to do is, like in the previous videos, have something in there, block through there, crack this nut off. It's not over tight, get that loose, under the nut, pulley off. Well, it's loose anyway, so I can do it. So imagine I've cracked it off, nuts off. Again, once the engine's installed in the car, this has a bit fiddly, but it'll give you a good indication of what issues you've got. Pop that off. What you can do then is undo those two bolts, which should be 13, I think. Yeah, so I'll just get a spanner and undo those. So yeah, so 13mm. These weren't tight anyway, because it's only just put back in there softly, so you know it's in there. Again, if you're going to take this off, you might as well change the seal, because it just makes sense to. They're not expensive, and if you got to the position it's off, just change it. Again, just get a little screwdriver behind there. This shouldn't be too tight because I've had it off anyway. And you've got the actual shaft seal, which is the black one you can see at the front, and then there's an O-ring on the actual outer casing. Again, don't force these things because parts are hard to get hold of. There you go. A little bit more. Right, remembering I've got no bearings in here, so this is going to move a lot more than what yours is on the engine. There we go. Right, so you've undone the bolts, ease that off. Obviously that's just WD-40 and stuff. So obviously I've got loads of play in there because I've got no bearings. So what you can do is gently pull this off. You only need that sort of much, and you'll be able to see with the car on the engine bay with a torch what condition that bearing's in. If it looks anything other than perfectly smooth, or from the side if the thickness top and bottom is different, then they're going to need to be changed, unfortunately, which again is an engine strip down job. Now you've got the shaft out, it's very easy to put back in. Slide it back in there just so it sits in there. As you push it in, it should just turn a little bit because you've got the gear on the end of there. So again, if you pull it out too far, that gear will drop down and be awkward. You can undo that and take the gear out, but we're not pulling out that far. So, and then just put it back in the reverse of how it was, changing those seals, making sure that hole lines up with the bottom of there, because that is your royal oil ways. And again, with the new seals, nuts up nice and tight. If you put in new seals and get a bit of oil on them, especially O-rings, because you don't want to nip them, and then the O-ring split, and then you end up leaking oil. And then cam's got a little keyway in it. Again, doesn't matter which way around it is, unless you've got an 8 valve, then it does. Pop. So there. So that is what you're looking at. So again, if you've got the engine's in there, you've got a bit of gap there, it can be awkward to see it, but that's if you only want to take it off to see if you've got problems with that bearing. And obviously with this, we know we did have. But again, if you get your cam belt tension right, if you have got slight wear in them, it shouldn't get any worse. It should hold itself where it is. And you can also, there's companies out there you can drain your oil out, send your oil away to them, and they can like test it for metal particles, and they can tell you where the metal particles come from in the engine, where the bottom, top and all that sort of stuff. So, hope you enjoyed the video. Simple things, get things right, and they should last a long time. These engines are known to last a long time. Generally VWs are anyway. So, thanks for watching. Catch you next time.